All right, hi everyone, welcome back. So we're gonna spend this video just introducing sampling distributions. And so in addition to having your note packet, which we'll pick up on page 7, you should also kind of be near a computer or a tablet to kind of follow along, since we'll be using StatKey, just like we used for the normal distribution. So the example that we're going to work with is this pet data. And so we have from the US Census that 68% of all families own a pet. And so the census asked this question, so we know for sure that the true population proportion of families in the US that own a pet is 0.68. So that's kind of cool, but we're gonna kind of use that to talk about how we would get a sampling distribution. And so our parameter, like we defined in the last video, we're usually going to denote with a lowercase p to represent the population proportion. And so this is one of the rare instances where we actually know our parameter of interest, because it's 0.68, because we did a census. We're going to investigate what this sampling distribution means and what it is for a sample size of 11. And so the lowercase n is what we're usually going to denote as sample size. And then if we took a sample size of 11 families and found the proportion who owned a pet, so maybe in our sample that was like 8 out of the 11, our sample proportion we're going to denote as p with like a little hat on its head. And so this is kind of pronounced like p hat. Before we get to StatKey, we're going to kind of imagine how you would actually construct a sampling distribution by hand, even though you would never actually do this. And so imagine like having 125 million pieces of paper where each different piece of paper represents the different families in the United States. And so on 85 million of them, you would write own a pet. On the other 40 million pieces of paper, you would write does not own a pet. To get this sampling distribution, what you would do is shuffle all those together, randomly select 11 of those pieces, and from those 11 pieces of paper, you'd record the proportion of families in the 11 that own a pet. So maybe you draw 11 and 6 of them say own a pet. And so you'd record 6 out of 11. You'd throw those back in, reshuffle, and then do step 3 again. So you draw 11 more, maybe the second time you did it, like 9 out of the 11 families owned a pet. And so you'd record the 9 out of 11, throw those 11 pieces of paper back in, reshuffle, draw 3 more, or draw 11 more pieces of paper, maybe this time 3 out of the 11 families own a pet, and so you'd record 3 out of 11. You'd end up doing that like thousands and thousands and thousands of times. Once you did that thousands and thousands and thousands of times, you'd have thousands and thousands and thousands of sample proportions. And so your sampling distribution would just be like a histogram of all of those sample proportions that you found from this steps 3 and 4, doing that over and over and over and over and over again. All right, so it's a little bit of a weird idea. So we're gonna jump to StatKey to kind of see it in action a little bit. And if that was a little bit unclear, hopefully using StatKey will kind of clear it up a bit. And so this link is posted on Sakai under announcements. We'll kind of keep an announcement going that has kind of all these relevant StatKey links, or you could open the PDF and click on it directly, whatever's easier for you. Once you open it, you should see this kind of blank graph from StatKey, and we're going to change a couple things so that it matches our example. And so the first thing we're going to change is this sample size. And so in our example, our sample size was just 11 because we were only thinking about sampling 11 families at a time. Our population proportion, here we also want to change that, and so we could click this Edit Proportion button up here. And our population proportion was 0.68 because we knew from the census that 68% of families own a pet. All right, and now what StatKey is going to let us do is build this sampling distribution we'll do it a little bit slowly. And so if you click Generate One Sample, you should see a little dot that represents the sample proportion from that one single sample of 11 people. So the first time, for our pieces of paper, it looks like we drew 8 pieces of paper that said owned a pet and 3 that didn't. And so our first sample proportion is 0.727, and so it gets marked on this histogram. To follow along with the note packet, you can continue writing, obviously, but since I'm on the computer, I'm gonna just type. Whoa. And so generate one sample. That just samples 11 families and records the sample proportion. All right, so as you're kind of writing, I know it'll probably take you longer to write than it does for me to type it. You could jump back and slowly kind of build up this sample or the sampling distribution. And so we said in our steps that we would be doing this like thousands and thousands of times. So I could generate another sample. In this case, it looks like 9 out of 11 families from that sample owned a pet. I could kind of keep going, generate another one, another one, another one, another one, another one, another one. They'll all just keep adding sample proportions to our or in this case dot plot. Instead of just clicking this like 1,000 times, you could jump to this generate 1,000 samples button, which will then do that 1,000 times and kind of stack the dots all on top of each other. And so when we say what a sampling distribution is, this is what we're referring to. It's usually a histogram or dot plot of these like thousands and thousands of sample proportions. And so we could write generate 1,000 samples that so what does that do? That samples 11 families and records the sample proportions, or records the sample proportion 1,000 different times. Okay, so let's kind of summarize all that in some steps for what we actually did to build this sampling distribution of our sample proportion. And so it is a weird idea, I know, but we'll end up using this both in confidence intervals and when we do kind of formal statistical hypothesis tests as well. And so kind of for our step one, we kind of just have for a given sample size, and so in this case we were denoting a sample size as n. Sample n families and record the sample proportion that own a pet. And so this was denoted as the P hat. I can't really type it here, but it was the little P with the hat on its head. So I'll scroll back up this thing. All right, so that was step 1. Step 2 was that we just want to repeat that step thousands of times. So that's kind of easy enough. And then from step 3, we just want to build a histogram or a dot plot of our thousands of sample proportions. All right, and then we're done. So this is just what a sampling distribution is. I know that we're kind of presenting it without really it having a purpose yet, but we'll see what its purpose is in very, very quickly. So we'll talk more about it in the next video as well, because it is this big concept. And so definitely feel free to kind of reach out and ask if you have any questions. Otherwise, sorry, this went over my 10-minute mark rule, but we'll kind of pick up here next time. So have a great morning, afternoon, evening, whatever time of day you're watching this video in.